Hello and welcome everyone. Thank you for joining us today for our latest knowledge sprint. I'm George Boulis, General Manager of Sales and Marketing here at Piranha. Today I'm joined by Jamie Constable, Head of Network Engineering, and Anthony Blackman, Head of Operations. Today we will discover how Piranha's Declarative Authorisation Service, or DAS for short, brings fine-grained, policy-driven access control to microservices, APIs, and containerized environments, thereby enabling organizations to implement zero trust security at scale. Today, Anthony will take us through a short presentation on DAS, or Declarative Authorization Service, followed up closely by a demonstration by Jamie of how it's configured and how it's implemented within our environment. Start us off, please, Anthony, with a description of what DAS is, please.
Thanks very much, George, and hello all. Welcome to our knowledge sprint on securing microservices. I will start quickly with a brief overview of Piranha itself and how we began, and then I'll move into the actual presentation. So we'll be running through the benefits and challenges of microservice architectures, especially in DevOps environments, and how we can use Crystal DAS to actually resolve them. We were founded in 2015, and we respond to key security needs identified within the business and enterprise space. Our platform, the Crystal is globally recognized for comprehensive threat management. We maintain a number of certifications: CREST, ISO IEC 27001 and ISO 9001, and we're members of Team Defence Australia and the Cyber Threat Alliance. One of our most unique offerings is our SOC as a service, but we've brought a lot more capability and service offering to the table. We hold that cybersecurity itself is cyclical, never-ending, and constantly evolving for every organization. Applying our 7 pillars model approach, we bring cybersecurity problems holistic solutions, combining product and service offerings to meet the objectives of any client, regardless of scale or industry. We've added to our product capability with Crystal 5.5, the Declarative Authorization Service, or DAS for short, a tool designed to assist organizations in managing the ever-increasing sprawl of microservices and APIs with clearly defined declarative policies that can be applied universally. This is intended to reduce confusion and risk, centralizing the management and the logging to add capacity to directly integrate threat intelligence, utilize policy decisions for investigations, and quickly identify the state of policy integration for any system for any time period in the system's history. Managing policy as code brings control back to compliance and infrastructure teams while reducing management overhead and the compliance bottlenecks that many are now familiar with. Before we begin, I would like to start with a clarification that is sometimes needed in our industry: authentication versus authorization. Authentication is the process of identity verification to ensure that a given user account is both valid and is being used by the correct person. This typically involves credential checking methods such as usernames, passwords, or biometrics like fingerprints or facial recognition. Multiple factors checked together or sequentially are often used to increase veracity. Authorization, which is the main focus of what we're talking about today, is the process of determining what resources a user is allowed to access and what actions they are allowed to take on those resources. This typically involves checking the user account against attributes attached to the account, roles that the user might have been assigned, or policy controls. The principle of least privilege is often applied here to ensure that user visibility and actions are constrained to only those required to conduct their tasks. So let's move on to some of the challenges that might be presented by development strategies like DevOps philosophies or those kinds of things. Docker containers give development teams speed, portability, and deployment reliability. These advantages come with challenges in scaling and control, necessitating security enforcement in a more deliberate manner. Containers multiply deployable units, increasing sprawl and introducing management overhead to prevent inconsistency. DevOps pipelines may push images directly to hosts or lightweight clusters, bypassing standard controls, especially if misconfigured. And these challenges introduce risks that must be controlled, from supply chain management through to auditability. Let's now explore how Declarative Authorization Service can assist in control implementation across development, staging, and production environments, from library import to runtime in a Docker environment. Continuous integration, continuous development pipelines bring great advantages, but with the aforementioned challenges and risks. So how can we resolve some of these? Policy implementation and enforcement can be applied. Many of the failures at the production level originate upstream, so we must shift left and introduce meaningful policy control at the earliest stages of development. Establishing policies to enforce linting, to maintain consistency, big enemy of security. We can enforce software bill of materials generation and establish acceptable vulnerability thresholds early in the pipeline to prevent risks ever breaking through even to staging or production environments. We can enforce trusted registries and signed images that can bring greater control. And further, we can enforce tamper evident attestation and change management to assist in governance efforts. Setting policy constraints at each promotion point can assist even further. But ultimately, these solutions also bring challenges, measurable costs and effort to implement, and bottlenecks in verifiable policy enforcement. Auditing can also become costly as scale increases. More development teams, more developers, more monitoring, and more policy management. At runtime, the challenges and risks continue, bringing the environment into closer contact with the threat landscape. Misconfigurations must be monitored, and the safety of the production hosts themselves must also be assured. Microservices in constant conversation form a background of chatter, sharing data that must be classified and controlled. Resource constraints become more obvious, with end user demands for constant availability adding layers of complexity to beleaguered policy enforcers. Now we get to look at some solutions, though. Crystal DAS, by leveraging existing technologies like Open Policy Agent, we can deliver centralized policy management. The decoupled policy engines can be deployed where they are closest to the protection targets, which is a key factor in security placement, and policy structures can be brought into and managed in a single location, the crystal eye. And then they can be applied across the entire pipeline at every single key point. Further, policies can be version controlled and managed as code, bringing the benefits of DevOps philosophies and mechanics to compliance and infrastructure teams. Code once, deploy everywhere, and manage simply, allowing the power multiplication effects inherent in CI/CD to apply universally, minimizing bottlenecks and improving productivity across organizations. As a precursor to the demonstration, here are some of the main benefits that can be seen through implementation of Crystal DAS, the kinds of benefits we are looking to take advantage of ourselves here in Red Piranha. We can block images from unapproved registries early and often with a single set of policies. We can block images containing critical vulnerabilities even in build environments, ensuring a smoother path to production. These respond to some of the risks I mentioned earlier. We can further block the latest image pools to reduce risks and enforce semantic or digest references, bringing unique keying and auditability to the process. We can also block code progress comprehensively at every point in the pipeline, limiting the risk of circumvention, improving the security of every stage from development all the way through to production. At runtime, we can set mandatory constraints like no privilege mode containers or binding to sensitive location. Again, latest pools come into effect here and the risks inherent there. As we continue development ourselves, and for those looking to build into their own development processes, we can go further and integrate with the centrally managed, fully decoupled policy stack and achieve this by building policy checks into wrapper scripts or new container engine plugins and hosted mission workflows. We can go even further to manage resources directly, like CPU usage, CPU usage and memory with highly granular policies, which can enforce resource thresholds in every environment based on individual or team assignments. We can force labeling for accountability and just reject any new container without a defined non-root user. Our solution here goes beyond also bringing the logging of decisions throughout all policy-controlled systems back to the crystal eye for potential correlation, integration into threat intelligence, and comprehensive auditability. putting control, again, back into the hands of compliance and infrastructure teams and allowing developers the freedom to chase their objectives in the knowledge that the security standards across all parts of their pipeline are consistently applied. I'm going to hand over now to Jamie for a demonstration of crystallized DAS. We've kept these deliberately simple, but they are demonstrative of the potential power.
Everyone, bear with me whilst I get my screen sharing sorted. All right. So here we have our declarative authorization service in Crystalline. As you can see, we've got 3 demo systems. The first thing I'll take you through is how easy it is to add a new system to the stack. So we've got a simple add button up here. We're just going to give it a name, 0, 0. We'll use one of the existing policies that we've already defined, which I'll talk about in a moment. So now we've got a new system that's ready for publishing. So we're simply going to go configure and publish. It's already pulled in that policy we defined in the creation part. We can view or edit it here. For now, I'm just going to publish the bundle. And now we have it ready to go published, and we now have a configure system button, which will provide us with a curl command to run on the system. So I'll jump over to that system now, and we can simply run that command. And it will do all of the work for us. Now that's complete, and we can go back to Crystalline. And it's now active, and those policies are now enforced per our policies that we've defined. Under the compliance tab here, you can see that we've got our 3 policies for our 3 different demo environments. This is where you would define additional policies. For now, I will jump over to Docker 1, which is going to demonstrate our supply chain. Again, this, as Anthony mentioned, we've kept these fairly simple. What this is going to demonstrate is defining a specific Docker registry that we can pull from. Think, for example, you've got an internal registry that is the approved registry. So, for example, if I try and pull from a public registry, I will simply get a denied. However, if I try and pull a system from the Docker registry.rp-demo, which is the one we've approved in the policy, it will run and download. And you can see that it's there ready to go. And that's demonstrated the, get the policy up, our supply chain policy. We also have a demonstration of our runtime environment. This one will demonstrate things like blocking the latest tag. So for example, if we try and pull Ubuntu latest, and this one doesn't have the same repository enforcement as the other one. Actually, it does, because that's the wrong Docker. You get Docker 2. So if we try and run the latest flag, it will be blocked because the policy does not allow latest. The policy also will not allow a container to run in privileged mode, which is not a default, but it still allows that to be blocked. Again, with the privilege tag is blocked. And same if we were to try and run with the security unconfined policy, and these are blocked. So what this policy does is will allow me to pull from a public repository, providing I don't do anything crazy or unsafe. we'll simply pull the policy, pull the container. So you can see that will allow me to pull an Ubuntu rolling, but not Ubuntu latest. Won't allow me to run anything in privilege mode or set unconfined. The next one we have, which is Docker 3, is our resource definitions. So what this one does is, again, if I try and run Ubuntu latest, and this one isn't blocking the latest tag, I'll get it denied because I haven't defined my CPU and memory. But if I do, for example, define those and pull the latest container, so I'm able to find it locally, and we'll pull it from the repository because I've defined the CPUs and memory restrictions that conforms to the policy requirements. So now that we've gone through those examples, if we come back to DAS, in Crystalline, we can look at our decision report. So in here, we can see on demo 1, we can see I tried to create a container, and we can see all of the output and digest from the log. But this was blocked because it was not pulling from our approved repository. Whereas you can see here, when I tried to pull the approved from the approved repository, it was approved to create, pulled the image, created all the things, and started up. The same goes for Docker 2. You can see I tried to pull the latest, rolling, etc., without the required things. So you can see they're all denied and they're all in this JSON output here. You can also export the reports into a JSON format that's a bit easier to read if you need. And again, the same goes for Docker 3. You can see that they're pulling the latest without the conditions met is a denied. And I guess I'll hand back to the floor if we want to ask any questions.
Can you just quickly show us the compliance report there as well? That's
sure.
an attestable report, essentially, to state, as I mentioned earlier, that the system has the policies applied, and you can check that for any point in time in its history. Obviously, it does have a polling time. I believe it's around 30 to 40 seconds. And that polling time means that there's a small differential between each of the notification points. But you can see there on the right there, that shows the full status of the policy being applied on the system itself. So you can know for sure and be able to establish to an auditor, for example, that the policies were in place. That's particularly beneficial for those seeking certifications and those kinds of things. All right, thanks for that, Jamie. I will take back the control. And
do you want to just give us the summary screen before I start reading out some questions, please, Anthony? Just to sum it all
yeah,
up.
for sure. Absolutely.
Got a couple of questions so far. So
that's fine. I'll just bring that back up. And look, I do have a little bit more to say before we do move on to questions, if that's all right. Crystalline Dask can be leveraged, of course, to implement policy control especially for businesses looking to deploy their own large language models, or AI if you prefer, especially in containerized microservice architectures with model context protocol. So
that's,
you can imagine.
That's if a customer chooses to spin up their own LLM in-house, right? Or
definitely. And look, I think that's going to become more common. I mean, even if we look at very simple environments like Docker Hub, there's, I think, around 20 to 25 LLMs that you can just spin up immediately. That's how ubiquitous they are becoming. On much larger environments, you'll find many, many more of those. So, I mean, there are a number of problems with this kind of deployment. There are a lot of risks associated with AI, and they need to be managed essentially the same way as all microservice systems need to be managed. So you can imagine some of the problems like unauthorized model deployment in your stack, or access by internal or external actors. The crystallized DAS can validate and enforce the results of access decisions by blocking or monitoring execution attempts and logging those policy violations in the crystalline itself. The benefit is obvious. It ensures that only authorized teams or services can promote models to sensitive environments like production, with DAS providing real-time enforcement and alerting. Think of some of the other problems that might exist there. So containers might be launched with excessive privileges, risking host compromise or resource abuse, as we mentioned earlier. Unsigned or unverified container images could compromise infrastructure through embedded malware. And the Crystal Eye can essentially intercept and block the execution of unsigned or unscanned images and log events directly to the Crystal Eye for SOC review. I guess finally, sensitive or regulated models must be protected from misuse or unauthorized access. They are particularly important, especially those that might have been given access to specific data repositories for specific work groups or task groups that are sensitive in nature, fully classified. So you can monitor the API and runtime usage. You can block access to regulated models if policy conditions aren't fully met. And this protects the models themselves that are trained on sensitive data sets by tightly controlling who can access them and who can use them, ensuring regulatory compliance. But it goes beyond that. You can also use it to control the service chatter. So there's a lot of service chatter in implementing LLMs, and you can control even that, treat them like a user, apply policy across the board, and allow microservices to only communicate with other microservices that they need to be able to. So that's it from me.
That you authorized.
That you have authorized. You are exactly correct. Thank you, George.
Thank you, Anthony. Thank you. We've got a couple of questions. I'll just run through them now. Please ask a question. We have another 10 minutes to go in our webinar, so we have time to answer. First one, how does policy authoring and management model of DAS differ from the RBAC-centric model in traditional API gateways, e.g. Kong, Apigee? Specifically, how does your declarative approach empower teams to develop and maintain secure microservices more efficiently?
Okay, so there's a lot to unpack there. RBAC and attribute-based models even, they rely fundamentally on the user model itself. You are applying the user either to a role or you are attaching an attribute to the user. And at the end of the day, that needs to be centrally managed and proactively managed. You can apply, for example, these are strong systems. They are in no way to be dismissed. However, policy authoring gives full context awareness, essentially, at the point that it is most needed. So by the time the policy question itself is sent, you've got all of the information you need in that context-aware environment to send the right JSON information directly to the policy engine, and the policy engine can make a decision based on all of the information present, rather than having to do this proactively or assign large groups of individuals into roles, for example. You can go down in these models for clarity into full granularity, but it requires excessive infrastructure management at that point. We can actually simply apply direct user control or team level control into the policy structure itself.
So just building lots of safety nets to catch wayward information. Lots of safety nets.
You can gateway them too, though. So you can build stages of access, things that general users can do, things that only specific users can do. All of those kinds of things can be applied. It's essentially the sky is the limit on what policies you can generate, because they are generated as code, and any information that you can receive by JSON can be acted upon or treated.
Excellent. Thank you, Anthony. Okay, next one. Microservices security is often fragmented across APIs, containers, and cloud environments. How does DAS unify the authorization policies to reduce risk, simplify governance across the layers? Basically, how do you take those disparate security elements and make them one?
Okay, so I think it's less about making them one than about centralizing the policy management itself. By bringing it into the Crystal Eye, you're controlling the policies from a single point, and then all of those systems can have the same set of policies or different policies applied to them based on their need, rather than having to manage them at the point of control itself. All of these systems have control structures in place, but by bringing the policy back into a centralized location and managing it as code, essentially reduce the overhead enormously, and you can pre-build all of your policies as well. So you can set your policy constraints before you even envisage what environment you're going to be spinning up in.
Okay. Do we have? Yes, we have time. Containers are ephemeral by design, making consistent security challenging. How does DAS handle dynamic workloads and ensure security policies remain enforceable at scale in a containerized environments?
Okay. Well, they are ephemeral by design to an extent. In production environments, obviously, microservices need to be kept alive for availability, but they can essentially be moved. I mean, that's part of the benefit, the raw portability of containers. So because the policies themselves are centrally managed, again, and they are separated from the process of managing the actual containers,
Right.
Quick integration then allows all of the policy rules to be applied immediately. There's no more ad hoc policy management, although the policies themselves can be coded explicitly for a single environment if you need it for edge casing. But then they can be configured again ahead of time. In some ways, the same answer as before. You can set all of your policy constraints well ahead of time. I guess here also you can reduce the time to delivery ultimately because they are ephemeral and because you can move them. You could choose to move from one environment to another, let's say AWS to Azure or something like that, to manage all of your systems. You've got a cost break. That's not really a problem. They're all containerized. You simply port all the containers over and they will immediately take up the policies as their systems are connected.
Okay, I think we've got time for one more, just in the next minute or so. With APIs increasingly being the primary attack vector, what role does DAS play in enforcing fine-grained, context-aware access controls that go beyond traditional perimeter security?
Okay. Okay, so with the implementation we have here, security and context are established at the protection point itself, for example, the API and its host. The policy check can be given all of the context and granularity. They're also fully decoupled. So any input can be sent to the policy engine as JSON, and you can define that ahead of time, but that carries the context itself. Like the JSON is defined where you actually need it most, with all of the information that is inherent in the system sending the request itself. All other information required for decisions is already there, essentially. You can also set default constraints, and I think that would be generally pretty wise, especially for sensitive systems. And that would ensure that there's a minimum quality of information to be provided. So let's say you design your policies well ahead of time, you might set the minimum constraints on the information that you receive, and if it's not there, then you'll get a default deny, and that will effectively enforce setting the right stage in those containers or wrappers or environments or even the API host to ensure that the users themselves are fully protected and the environment itself is fully protected before it can go live.
So basically a multi-API type constraint that is not limited by that security setup for that particular API.
You're certainly not even limited by the API itself or the host environment of the API, in a sense. It is relatively early stages. The implementation now is with Docker, and I happen to know that Kubernetes will be available very, very soon. It's already in final testing and will be released likely next month. And this is a continuous development project for us. So there's still a lot to do, but there's a lot of power here already and more to come.
Excellent, excellent. I think that does us for time. Thank you, everybody, for joining us. Hopefully this shared a bit more information about how we are securing your APIs, your containers, and not just a perimeter-based approach. Thank you, and stay tuned for our next knowledge sprint. Thank you.
Thanks, everyone.
Thank you.